Okay, so thanks, Fabrice. That was a very good overview of Lightning and how it works. So this talk was supposed to be on lessons I've learned running a Lightning node and building on Lightning. And I'm going to focus actually on routing because that's one of the biggest pain points of running a Lightning node and just using Lightning in general. So I'll begin with how routing works and finding peers, and then how to get some incoming capacity to your node and maintaining the capacity that you establish, and finally some lessons learned for how to become a more functional node and contribute to the network. So route formation is every node that is sending a payment does their own route formation. And this isn't actually defined in the protocol, and it's left open-ended because there's not really a best way right now to route a payment from the sender to the receiver. So every node has their own view of the network. It might not be a complete view, but it's their own local view. And based on what they know about the network, like the channel capacities and which nodes have channels open to each other, the ascending node will find some number of shortest paths to route to try for their payment. And as Fabrice mentioned, Lightning uses onion routing. So every intermediate node along the way that's forwarding a payment only knows what came before it and where it's going next. So they can't really help out the sender in finding the best route. So with onion routing, this means that there's a lot more privacy and senders have more anonymity, and it also makes the routing a bit flexible. So the sender creates its list of shortest paths, and this is generally implemented as a breadth first search or a best first search, and it finds the cheapest path according to things like the fees being charged along the way and the total delay that's going to be added to the time lock contract, because every node wants to make sure that the payment it's sending out doesn't expire, or the payment it's receiving doesn't expire before the payment it's sending out. So in this example, we have node C trying to send a payment to node H, and it has these three different paths it wants to try. One goes through E and F and H, and the next one goes through C, D, F, H. And the Lightning nodes do some error reporting. So if node C first tries to send a payment through E, F, and H, and and this one fails, F can report that this channel no longer works. And then node C knows to skip the next route and go straight to C, E, G, H and try that route. And in theory, the sender node will have enough routes to try that something will work and the payment will go through. In practice, a lot of new users end up seeing stuff like this. The payment fails a lot, and their wallet says they couldn't find a path to the destination, and this is bad. It causes new users to complain, and people on Twitter then say Lightning doesn't scale, and it propagates a lot of FUD. So our goal here is to learn or figure out how to run a node to minimize the chances of this occurring for both people who are sending payments and receiving payments. So we'll start off with how node discovery and channel formation works. Lightning is defined using the basis of Lightning technology. Fabrice went over most of these. So when joining the network, when first starting out, nodes need peers. And Lightning nodes Lightning nodes join the network through DNS, just like Bitcoin, and a new node doesn't actually know anything about the rest of the network. So there's a DNS seed server, and it returns a random set of peers for a new node to use. And this is also helpful because if a node goes offline for a bit and then comes back with a different IP address, the server can, the DNS seed server can also have that index. So it provides a way to query for existing nodes. And once nodes have peers, then they pass messages amongst each other through a gossiping protocol. So they quickly learn more about what other nodes are available in the network. So so when a node joins the networks, it connects the peers automatically. And having a node connected to peers isn't enough. They have to open channels to actually be useful. And we're going to walk through the process of opening channels tomorrow at the workshop. But for now, the quick rundown of how opening a channel works is, suppose A wants to open a channel with B. A sends B an open channel message, and the message defines the parameters of the channel. And this is basically like the funding amount, the fees. And B, for the most part, will accept the channel. The recipient node might disagree on the fee rates, as Fabrice mentioned. But usually, most Lightning nodes are just going to use the default settings, and then the channel gets accepted. So when a channel is created, this basically is you can basically think of a channel, an open channel, as a smart contract. Node A is creating the offer of entering into a contract with B, and B can accept. And each channel has something known as a revocation base point, and this is used as the leverage for in case the contract is breached and one party misbehaves. So once the contract is accepted, A creates the funding transaction, B signs it, then the transaction is broadcast, and after some number of confirmations, this channel is available for use. So in this example, we'll pretend that this is just a private channel between A and B, and it's not being used to forward payments or anything. So as A sends money to B, we see continuous update messages from A to B saying they want to update the state of the channel, which means that dictates how the funds are split between A and B. Because when starting out, if A funds the channel, it all starts out on A's side, and then we gradually push some amount of funds to B. And each update comes with a commitment message, and once a new transaction is, or once a new state is committed, then B replies with the revoke, and this is where they exchange the secret that is needed to basically seize the funds in the channel if an older state is broadcasted. So if an older state is broadcasted, then I don't know if you guys can see this piece of script right here, but this is basically the code that governs the smart contract. It says that if someone has the revocation key, then they can seize the funds that are in that transaction. And the revocation key for a previous commit is shared each time a new commit is added. Now, if the channel funder, A, disappears, it's not that big of a deal. It's kind of annoying for B, but they can broadcast the most recent transaction, and after some delay, they claim the balance that they're owed. But it's more annoying for the funder of the channel if if channel B disappears. Basically, channel A, when opening a channel, is tying up some amount of Bitcoin. It means that whatever they put into the channel is not available until after the timeout period if B disappears. So that represents an opportunity cost for A because it means that Bitcoin can't be used, and it can't be earning money from network fees. So the channel is basically wasted if the counterparty disappears. Since A gets penalized if the counterparty disappears, that means that when creating channels, a node needs to be careful to find good peers. And one of the biggest or one of the most important factors in selecting a peer is reliability. You want to connect to nodes that are going to be there for you when you want to use the channel. So 1ml.com is a popular resource. It lists the nodes that are with the most capacity and with the top channel count. And this is a good way to find nodes that maximize connectivity to the network, because if a node has a lot of channels and a lot of capacity, then it's probably going to be a useful node for routing. And the better connected a node is, the fewer routing nodes you'll need. But I mean, it's also suboptimal if everyone goes and connects to the most connected node, because that just means we have a very centralized network. So LND is one Lightning implementation. It's the Go implementation, and it has a feature called autopilot. And autopilot is a service that will automatically choose channels to open for the user. And autopilot is currently not recommended for mainnet, but it's good to understand how autopilot works, and it'll help us understand what we're trying to achieve when building out the Lightning network. So autopilot selects nodes for the user to connect or to open channels to, and the probability, and the nodes are randomly selected, but the probability is higher of connecting to a node if it has a lot of existing channels. So it follows a power law distribution, and the goal of autopilot, if everyone's using autopilot, is that the Lightning Network will turn into a global scale-free network. And that just means that there are a lot of hubs and a lot of spokes. And the hub and spoke model sometimes gets a bad rap because hubs suggest that the network is very centralized. But most social networks, most networks in general, tend to be scale-free networks where there are super connectors that are like hubs, and nodes cluster around them. So this makes communication more efficient, and having multiple hubs reduces the risk of a single point of failure. So in these images down here, you can see how a scale-free network grows over time as the new nodes join and add connections by randomly selecting existing nodes based on the number of existing channels they have. So there are a lot of limitations to using autopilot, even though it's a good first pass. And the autopilot feature in LND right now is a stub, so it can be substituted for like other strategies for channel formation. But the thing with autopilot is it doesn't take pathfinding into account, and every new user who uses Lightning is going to have different needs as far as what channels they'll need to use most. One big drawback, and actually it's necessary, is that there are privacy trade-offs when using Lightning. The channel balance, like the amount of funds on each side of a channel, this is not public information. we can see the capacity of each channel in the network because you can see the funding transaction and how much Bitcoin was committed, but you don't know all the intermediate transactions. So you don't know if all the funds are still sitting on one side. And I mean, that's a good thing for privacy, because if we could see the funds flow throughout the network, then that would make it really obvious who is sending money to whom. We also have limited information about a node's reliability and uptime when just using autopilot to select channels. And for a lot of users, they're probably going to shop at the same few stores over and over again. So they would want to optimize for the best path for a few favorite destinations, and have and take redundancy into account if they're trying to hit the same node over and over again. Okay, so now we know how to create outbound channels and have outgoing capacity for paying people, but we also want to know how to make it easier for other people to send money to us, because you can create all the channels you want and fund them with tons of Bitcoin, but that doesn't guarantee that you'll be able to receive money. So as we saw previously, having a channel open to you means that it is a pretty big risk for the person who opens the channel. The counterparty of a channel is a party to a contract, so they're making a commitment. They're committing to making the channel available when it's needed. So, and an unresponsive node can cause problems not just for the counterparty of the channel, but for everyone in the network if it's a public channel. If the counterparty of the channel goes offline and other people still see it as a public channel, they could try to send money or route money through it and have routing failures. And that's bad. We want to avoid that. So in order to become an attractive node for getting inbound channels, you have to basically be a good routing node. Another option is to build a popular service where people will actually want to be paying you. So I mean, that is a pretty big hurdle to build a popular service where everyone wants to connect to you. So probably the option that is most useful for people is to have the money that you put into it, or be able to fund the channel yourself, be able to fund inbound channels. So one option is to create an outbound channel to someone else and then spend money, put the money out into the network, and then the newly open channel now has a balance on both sides, which means you can receive money through the same channel that you just opened. There are other options for exchanging on-chain capacity for Lightning-based capacity. So one example is a custodial swap, where you're trading Bitcoin on-chain in exchange for a Lightning channel that's funded. And one exchange that does this is Zigzag, and having or buying Bitcoin on an exchange and having it and automatically receiving it as a payment channel means you have fewer on-chain transactions than if you were to buy the Bitcoin, then go out of your way to open a channel. You can also perform non-custodial swaps. As we saw previously, we can create on-chain transactions where the balance of the transaction can only be claimed if you have a payment preimage. And this is, for example, a submarine swap is when you exchange a Bitcoin transaction for a Lightning or a paid Lightning invoice for a paid Lightning invoice. And SparkSwap is an exchange that is trying to do trust minimized non-custodial swaps. It just hosts the order book and enables people to create non-custodial atomic swaps. All right, so ideally we've created some channels with outbound liquidity, and we have acted as a good node. So people have, we now have inbound channel capacity. Now we want to maintain this, and part of the main reason why payments fail is that the sender couldn't find a route to the receiver. One possible reason for this is that the payment was too large. Even though the advertised capacity might have been sufficient, the balance or the channels might not have had the appropriate balance for routing the payment. So for exceptionally large payments, oftentimes the transaction is better off on chain, because sending a large routing a large payment through nodes unbalances all the channels that it goes through. And that's also why they charge higher fees. Another reason why payments often fail is that nodes made public channels when they probably should have kept private channels. And it can be frustrating for the sender if a node went offline and left a zombie channel that still looks like it's active. So nodes are always passing messages and sharing gossip about each other. So it is possible to update information about a channel. If a channel goes offline, you can update the channel with a disable flag, and that information will be propagated. So even though the channel did look like it was active, it can be disabled when it stops working. So one more thing is not everyone has to be a routing node. Most Lightning participants are probably just going to be primarily senders or receivers. And here I'll invoke Adam Smith and the idea of division of labor. Eventually, we're going to have specialized nodes that are really good at routing, and nodes that don't need to do that. So a Lightning node that functions as part of a storefront will be able to focus on doing its job of running a store and not worry about the routing part. So a lot of Lightning-powered stores might not even want to have public channels or public inbound channels. If the store is selling stuff that is embarrassing, or that people don't want to, or that the customers don't want other people to know about, then all the inbound channels could potentially be private. And when generating an invoice, a node can provide routing hints in the invoice. So even if the sender node doesn't know about all the paths to the recipient can say, hey, there are some private channels that you can use to send the payment to me. And the sender of the payment isn't required to use the hints, but it can be added to the pathfinding process, and it can make it easier for a sender to get to the destination, even if not all the channels are advertised. So the most important lessons learned, I guess, if you're maintaining a public channel that's advertised to the network, keep the channel balanced so fees can go, or so that funds can travel both ways, because most Lightning nodes aren't going to know about which side the funds are on So it's best to keep the channel balanced. And it's also good to start small, because if you advertise a very large capacity channel, then you become a you become a risk to all the other participants. I'm not sure if all implementations support this yet, but you can also have channels that charge a negative fee to encourage routing through your channel if it becomes unbalanced. Another lesson is to shut down gracefully and actually do a collaborative close. Send a close request to the counterparty of a channel if you want to close the channel, rather than just shutting your computer off and leaving them hanging. It's also beneficial for the network as a whole if the bad nodes are appropriately punished. So if a counterparty to a channel suddenly goes offline, then the person should disable the channel and close offline channels. The person who, the funder of a channel is generally responsible for the fees, so make sure they are out of luck if they disappear. And there are things that that are still in the works for Lightning, and in the future, Lightning will become a lot easier to use than it is today. For example, atomic multipath transactions. Right now, it can be very hard to find enough capacity for a larger payment. It's hard to find enough channels that can support a large payment. So atomic multipath transactions will allow you to break up the payment and route it through multiple, take different routes to recombine the payment at the endpoint. And in the future, there will be splicing where you can resize channels that are already open, and channel factories where a single channel can be used to create lots more channels. And this is all minimizing the amount of time or the amount of transactions you have to do on chain. And in the future, we'll also, Lightning nodes will have access to more information and make better decisions about how to open channels and whom to connect to. Nodes should be able to track more information about the history of their peers. For example, right now you can sort of figure out if a node has been involved in non-collaborative channel closes, if they've left their counterparty hanging, because you can go onto a block explorer and look at the funding transaction and see if that transaction caused a time lock. If a transaction caused a time lock, that probably means that this node was involved in a unilateral close. It closed the channel without without collaborating, or the channel was closed not as a collaborative close, but as a one-sided close. And you would probably want to avoid opening channels with someone who causes unilateral closes. And finally, this is a picture of the Lightning Network about a year ago, and there were 40 nodes and not a whole lot of channels. And in 1 year, this is what the Lightning Network looks like today. And this is just what's publicly available. As you can see, it didn't turn into a totally centralized network where there's just one hub and everyone's connected to it. But it does look like a scale-free network where there are lots of options for super connecting nodes. So as the network grows, hopefully we'll see less of these payment failures and more successes. And that's all I have.